Hello, hi friends and students. This is Naresh. I am teaching mathematics to you. I am doing video classes about TET syllabus. If you are preparing for TET, keep watching my channel. If you are watching first time my channel, please subscribe. Don't forget. And let's begin the class. So in previous class we have discussed about prime factorization. Okay. So in this class we are going to discuss about LCM and HCF. Kasagu, Gasaba, Kanishta Samanya, Gunijam, Garishta Samanya Bhajakam. Okay, so LCM HCF we can find in three methods. So what are the three methods? First one, if you are going to find LCM means by writing multiples. LCM means least common multiple. Okay, so by writing multiples. Next other one is by prime factorization. If you don't know prime factorization, you can watch previous video, you can understand easily. Okay, so next finally synthetic division method. Okay, so to find HCF also we have three methods: by writing factors, again prime factorization, and continued division method. Okay, these are the three methods. So first I am going to explain about LCM. You can understand very easily. I am going to take three numbers here. So LCM, least common multiples. So first multiples. What are the multiples? A number multiplied by natural numbers, you can get multiple. For example, one number I am taking 5. If you multiply with natural numbers, you can get its multiples. 5 ones are, what are the natural numbers? 1 2 3 4 sahaja sankhyalu. Okay, 5 ones are 5, 5 twos are 10, 15, 20, 25, like this. Okay, so these are called multiples of 5. 5 యొక్క గుణిజాలు. Okay, so like that we can write multiples. So first I am taking one problem. Three numbers are 6, 9, 12. I am taking three numbers here. Okay, so now here for these three numbers we are going to find LCM, least common multiple. So first we have to by writing multiples I am going to explain. By writing multiples, so first 6 multiples I am writing. Okay, what are the 6 multiples? 6, 12, 18, 24, 30, 36, okay, and 42, 48, 54, 60, 66, 72, so on. Okay, so these are the multiples of 6. Infinite are there, multiples are infinite. And you remember one thing, its smallest multiple is itself. Okay, 6, smallest one. Now which is the greatest one means we cannot be determined. So same like that, 9 multiples I am going to write. 9 and 18, 27, 36, 45, 54, 63, 72, 70, okay, sorry, 81, so on, like this. These are the multiples of 9. And 12 multiples: 12, 24, 36, 48, 60, 72, 84, so on, like this. So these are the multiples of 6, 9, 12. Okay, now by writing multiples we are going to find LCM. So LCM, least common multiples. First we have to take common multiples. What are the common multiples here? So if you see here 36 is there, here 36, here also 36. So this 36 is common to both three numbers. Okay, so first common multiple is 36. Next common multiple you are getting here 72. Okay, so next 72. Next you will get 108, so on, like this. Why I am saying like this means because 36 ones are 36, 36 twos are 72. So 36 threes are 108, like that. So 36 fours are also like that. Now you need to understand common multiples of these three. You are getting 36 multiples. Okay, so now these are the common multiples. In this common which is small, least, kanishta samanya gunijam, these all, okay, kanishta samanya gunijam, which is the smallest, least one, this is the 36. So 36 is LCM of 6, 9, 12. This is LCM process by writing multiples. Okay, so next prime factorization method I am going to find. So this is 36. You need to understand this is very long process. Okay, so next I am going to do prime factorization. What is the prime factorization? 6 we have to write into prime factors. 2 divisible, 2 3s are and 3 1s are. So 6 is equals 2 into 3. We can write 2 to the power of 1, 3 to the power of 1. And 9 you know that directly we can write 3 3s are. Okay, so 9 equals 3 into 3. This one we can write as 3 to the power of 2. Next 12. 2 6 are 12, 2 3s are and 3 1s are. This is prime factorization, already we have done in previous classes. So if you want you can check the video. So 2 into 3. This one we can write 2 square into 3 to the power of 1. So I have written the 3 numbers in prime factors. These are the prime factors of 6. This is the prime factor of 9. So like that I have written. Okay. Now how can you take the LCM? So LCM how can you take? Remember one thing, process. So for common thing, least, opposite, highest. What are the common in these 3? 3 is the common prime factor to 3. So in this highest exponent means this one. 3 square is there. 3 to the power of 1, 3 to the power of 1, 1, 2, 1. Which is the highest? This is only highest. So for common factors, you have to take highest exponent which is having, okay, into. Now remaining. So here also in this remaining is 2, in this also remaining. In these two, which is the highest? 2 square. Okay. Now is there anything, if you have any remaining, for example into 5 is there, you have to take 5, but there is no any other thing except common these only. So now we can write 3 square means 9, 2 square means 4, 9 4s are 36. So this is also LCM. By which method? This is prime factorization method. Okay, the final method is synthetic division method. What is the synthetic division method? 6 9 12 you have to take like this. Okay, three numbers I have taken, 6 9 12. Okay, so now you have to take the divisor here. Divisor, how can you take the divisor? Means it should divides at least 2 numbers in this, at least 2 numbers. If you observe 6 and 12 both are divisible by 2. ఇవి రెండు నెంబర్లు మనం 2 చే భాగించబడును. సో I am taking 2. So 2 3s are, and which is not divisible you need to take continue as it is. 9 is not divisible, I am taking as it is. So 2 6 are 12. And next, so no, these are not divisible by 2, and if you observe these 3 are divisible by 3. 3 1s are, 3 3s are, 3 2s are. Okay, so again you can observe these are primes. Primes means no common other divisor, so we can take again 3 1s 1, it is not divisible as it is. Again 2 1 1 1 up to this process you have to do. So multiply these all, you can get LCM. So 2 into 3 into 3 into 2, 2 3s are 6, 6 3s are 18, 18 2s are 36. So this is LCM process by 3 methods. By writing multiples, LCM least common multiple, kanishta samanya gunijam, these are called gunijal, okay, multiples. So now here by writing multiples, this is by prime factorization, this is by synthetic division method. Okay, so you can capture this if you want. I am going to rub. This is about LCM. Next I am going to explain about HCF, highest common factor. So it is also having 3 methods. What are the 3 methods? First, by writing factors, highest common factor by writing factors and by prime factorization. Next final one, continued division method. Okay, so for I am taking the numbers, so 120 and 72, 192. So by writing factors, first I am going to do, first I have to write 120 factors. Already in previous class explained writing process. So prime factorization first we have to do. So two 60s are, 2 30s are, okay, 2 15s and 3 5s and 5 1s. Now we can write 120 factors. What are the factors of 120? 1 is factor of every number. Okay, first you have to start with 1. Now here you have to check 2 is there, yes, 2, yes, 3 is there, yes, 5, okay, like that we have to take. Next now 2, first 2, multiply with remaining, 2 2s are 4, 2 3s are 6, so 2 5s are 10, like that. Next 2 2s are 4, 4 2s are 8, 4 3s are 12, 4 5s are 20. So this product I have taken. Next up to here I am taking 3 digits, 8. So 8 3s are 24, 8 5s are 40. Okay, so next 8 3s are 24, 24 5s are 120. Okay, so upwards finished and downwards I am going to do. So 5 3s are 15, 5 2s are 10, already we got, okay, no need. Next 5 3s are 15, 15 2s are 30, okay, again 2 only, so no need to do, and 30, 30 2s are 60, 60. Next and 60, 62s are 120, like that you are getting. Next you can take pairs, 6 2s are 12, over 6 5s are 30, finished. Okay, so these are the factors of 120. Next 72 I am going to write 2 36, 2 18s, 2 9s, 3 1s, 3 3s, sorry, 3 1s. This is a prime factorization. Now again 72 factors I am writing. 1 is factor of every number and 2 is there and 3 is there. Next upwards 2 2s are 4, 2 3s are 6, okay. Next 2 2s are 4, 4 2s are 8, 8 and 4 3s are 12, finished. And 8 3s are 24, 8 3s are 24, again same only, 24 3s are 72. So now onwards 9 9s are, sorry, 3 3s are 9 and 3 2s are 6, already we got, and 3 3s are 9, 9 2s are 18, okay, right. And 3 2s are 6, 6 2s are 12, we have taken already. So these, and 192 factors. 2 9s are 18 and 6, 2 4s are 8, 4s are 16, okay, sorry, 2 8s are, and 2 24s, 2 12s, 2 6, 2 3s, okay, 3 1s. Next, so 192 factors. So 1 and 2 and 3, okay, so like the 2 2s are 4 and 2 3s are 6. So again 2 2s are 4, 4 2s are 8, 4 3s are 12. Next 8 2s are 16, 8 3s are 24. So up to here 8, okay. So next 16 2s are 32 and 16 3s are 48. So like that we can write factors. And 16, okay, 32 2s are 64 and 64 3s are 192, like that we can write factors. Okay, so now in these, what are the common factors you have to check? So 2 is there, 2 is there, 2 is here, so we can get 2 is common factor, and 4 is there, 4 is common factor, okay. So like that you are getting, and 8 also common factor, 2 4 8, so on, like this you are getting. So these are the common factors, but which is the so highest one, so highest one we have to take 8 12 and Oh, 14 not there. Next 20. So 40, 24, 24, 24 is there. 24. Any other one common? So no. It's enough. 24. Yes, so these are the common factors. In this, the highest one is 24. This is called highest common factor. Highest common factor. This is by writing factors. It is lengthy process, but process just you have to know now. That's why I am explaining. Next, easy process. I am going to say the prime factorization and continued division method. So this is by writing factors. And next, prime factorization process. So 120 prime factors. How can you write? 260s are. So already we have written 230s are, 215s, okay, 3 5s, 5 1s. So 120 we can write as 2 into 2 into 2 into 3 into 5. Okay. So this one we can write 2 to the power of 3, 3 to the power of 1, 5 to the power of 1. So next, 72 we can write 236, 2 18s, 2 9s and 3 3s, 3 1s. So 72 we can write as 2 into 2 into 2 into 3 into 3. This one we can write as 2 to the power of 3, 3 to the power of 2. So finally 192, 2 9s are 18, 2 6s are, 2 4s are, 2 8s are, 2 24s, 2 12s, 2 6, 2 3s, 3 1s. So 1 2 3 4 5 6, 2 to the power of 6 I am writing 2 to the power of 6 and 3 to the power of 1. Okay, so this is prime factorization. Already we have written. How can you take the highest common factor of these means? So only we have to take common prime factors. We have to check common prime factors. Highest means least one, least exponent, which is having least exponent you have to take. So 2 is common, 2 is common, 2 is common, but least exponent is 2 to the power of 3. So 2 to the power of 3. Okay. Next, if you observe these 3 also common factor. In these 3 is common. Okay. So but highest opposite, least one, least exponent, here 2, here 1, here 1. So least one is 3. Like that you have to take. 2 cube means 2 to the power of 2 and 4, sorry, 2 to the power of 4. 2 into 2 4, 4 2s are 8, 8 into 3. So 8 3s are 24. This is also HCF by prime factorization method. Okay. So next, one more method. In competitive exams also you have to use that method. So continued division method. So very easy process I am going to do. So in these 3, 120 and 72, 192. In these 3, so which is first you take highest one. This is highest. These 2 I am taking. So continued division method. We have to divide the 192 with 120. Okay. So 120 1s are 120, 122s are 240. It is crossing only one time. You take 120, you are getting 272. So now process is this, it will be divisor. We have to take dividend as divisor. So what is the dividend here? 120. 72 1s are 72. Okay. So now here we are getting 8, 28 and 48. Fine. Directly I am writing 48. Next 72, 48 1s are 48. Okay. So 10, 6, 4 and here 6, 24. And finally you are getting 24, here 48. 24 2s are 48. Remainder you are getting 0. Okay. So remainder, when you get 0, the last divisor is called highest common factor. Okay. So this is called continued division method. So this is 24 is highest common factor for 120 and 192. What about 72 means? Now you have to do the process 24 with 72. Same process. 72 24. Okay. So 24 3s are 72. Directly you are getting remainder 0. So this is 24 is called highest common factor. This is called continued division method. So HCF 3 methods are there. Garishta Samanya Bhajakam. By writing factors, already explained, this is by prime factorization. This one is called by continued division method. Okay, so in exams you can use continued division method to find the HCF, and LCM also you need to use synthetic division method. Last one I explained like that. And here some shortcuts I am going to say that. First of all, two numbers are there, for example 6 and 36, one pair is there. In this, for these two directly we can say HCF and LCM. How? Because here the 6 is factor of 36. When the number is factor of other number, then this factor will be HCF. HCF of 36 and 6 is 6 only. Then LCM will be 36. LCM is 36. Okay, so like that. Next, if the numbers are co-primes. Co-primes means their common factor is 1. Already we know that. For example, 3 and 17 I am taking. Okay, these are two prime numbers. Two prime numbers means automatically we can call Sahapradhana Sankyalu. Okay, co-primes. When these are co-primes, their HCF should be 1. HCF is 1. No need to do the process. Directly we can say these are co-primes. If they are co-primes, their HCF is 1. Highest common factor is 1. And LCM, Kanishta Samanya Gunijam, okay, their product means 3 into 17, okay, 21 and 51. So 51 is the LCM of these two numbers. Okay, so like that, HCF and LCM, if the factors itself, one of the number is factor of other, we can say that is only HCF and the multiple is LCM. Okay, and two numbers are primes also, we can say their HCF is 1, their LCM is their product. Sometimes no need to be primes also, but co-primes. How can you say co-primes? For example, here 4 and 15 I am taking. So 4 and 15 are not prime numbers, but they are called co-primes, because here 15 is not divisible by 4. So no other common factor you can see. 1, 2, 4, here 1, 3, 5, 15. So highest common factor is 1. These are called co-primes. Their HCF is 1. Their LCM also their product. Okay, so what is the LCM means? 60 you will get. 60 is the LCM of these two, because these two are called co-primes, Sahapradhana Sankyalu. Okay, so this is about LCM and HCF. Okay, once again revising, HCF how can you find? In 3 methods: by writing factors, prime factorization, and continued division method. Okay, in competitive exams you have to use continued division method. In LCM also by writing multiples and prime factorization and synthetic division method. Okay, sorry, synthetic division method. Next, in the directly he may give the prime factorization of numbers. Then how can you take the LCM and HCF? I want to finish with that. So for example, one numbers are 2 to the power of 5, 3 to the power of 7, 11 to the power of 4. This is one number, and one more number I am taking 2 to the power of 7, 5 to the power of 4, and 11 to the power of 2, and 7 to the power of 5. So for these two numbers I am going to write HCF and LCM. How can you write? First HCF. So remember one thing, highest common factor, Garishta Samanya Bhajakam. How can you take this? Means only for, you have to think about common prime factors. What are the common? 2 is common, 2 is common. Okay, 2 is common. Next, any other common? 11 is common. Only for this common we have to take which are having least exponent, very least exponent. So 2 to the power of 5, 2 to the power of 7. So 5 is the least exponent. Then you can take directly 2 to the power of 5 if they are common only. Otherwise no need to take. And 11 is common. Its lowest exponent is 11 to the power of 2. Okay. So by multiplying these you can get, means for example this is 32 into 121, like that. If you multiply them you can get HCF, highest common factor. But how can you take LCM? So I hope you understood this one. How can you take? Only for common prime factors which are having least exponent, takwa exponent unnai teesukovali. Okay, so LCM how can you take? Means first for common, LCM least, opposite highest. okay, which are having highest exponent. For common only first, so 2 to the power of 7, this is highest exponent. 11 to the power of 2, 11 to the power of 4, 11 to the power of 4. Now some work is remaining. What is that? Means we have to take remaining also. What are the remaining? So in this, for these two common we have taken, what is the remaining? 3 to the power of 7 into, okay. Next, in this 2 here, 11 finished. What are the remaining? 5 to the power of 4 into and 7 to the power of 5. This is called LCM of these two numbers, okay. If he has given in the prime factors form, then you can write like this. So HCF, how can you take? So for common prime factors, only which are having least exponents you have to take. Remaining no need to take, only this is the HCF process. But LCM you need to take highest exponents which are having common prime factors, highest exponent, and remaining factors also we need to take. So this is the process. You may get some bits on this in exams, so this is very useful, and this is continued division method you have to use in competitive exams. Thank you everybody. I hope you understood this concept, LCM and HCF. Okay, you enjoyed the class. If you feel that it is having good information, please like and share my video, subscribe my channel. Okay, bye bye.